Hello everyone, I hope you're doing well today. We're in the middle of our study of chemical equations and we're working on balancing chemical equations. I gave you a video last Thursday, I hope you had an opportunity to review that one. I'm going to present the first 5 of the problems that were assigned on Monday today. I'm going to work through them in detail. Then I'll give you an opportunity to finish the other 5 that I gave you on Monday, and I'm giving you 5 more for a total of 15 this week. Please work through those problems, make sure you're okay with them, and understand how to balance equations, because the next topic we're going to be going into is stoichiometry, which will require you to be able to balance chemical equations. I hope you enjoy today's lesson. Balancing chemical equations, practice. As I said before, we're going to be working through the first 5 of the problems that I gave you on Monday to make sure you understand how to work these step by step. The basic setup for a chemical equation is you have your reactants on the left and your products on the right. Reactants, as you know, are made up of elements and compounds, and the products are also made up of elements and compounds. The trick about balancing chemical equations is, think of it just like a scale. You have to have the same number of every element on this side as on this side to keep it nice and balanced, so that one side doesn't have more than the other. Take a look at problem number 1. We have aluminum nitrogen making aluminum nitride. Now the trick is, when you're balancing a chemical equation, the way that I like to work them is I like to list all of the elements. I split it down the middle. I list all the elements on the left. I have aluminum and nitrogen, aluminum and nitrogen, and then count them. This is 1 aluminum and 2 nitrogens. Then I go to the other side. I have 1 aluminum and 1 nitrogen. Now, a little heads up of a trick that I think will help you out a bunch when you're working these problems. Always be sure to list the elements in the same order on the left and on the right. I have aluminum here, nitrogen here, nitrogen here. That way I can compare them. Well, when I compare, I have 1 aluminum. Well, they're okay. I don't have to do anything with the aluminum. 2 nitrogen, 1 nitrogen. I need to fix that. So the only thing I can do to balance a chemical equation is add what we call a coefficient. That is a number that goes in the front. I can only add coefficient here, here, or here. I can't do anything. I can't change subscripts because that would change the chemical composition. All I can do is add coefficients. So to make these nitrogens, I have 2 on this side on the left to 2 on the right. I need to add a 2 right here. Well, when I add the 2 in front of the aluminum nitride, that changes the aluminum to a 2, so it's no longer balanced. The nitrogen to a 2, so it is happy. And now I need to go back to the equation and balance it out for the aluminum by placing a 2 right here. So the balanced chemical equation is 2 aluminum plus 1 nitrogen produces 2 aluminum nitrides. It's 2 aluminums, 2 aluminums, 2 nitrogens, 2 nitrogens, and that is a balanced equation. Yay, it's happy. Let's take a look at number 2. Again, I have iron and oxygen involved in this chemical equation. And so I have FeO, and on the right, Fe and O. Again, I just need to count everything. 1 iron, 2 oxygen, 3 iron, 4 oxygen. So neither the iron nor the oxygen is balanced in this problem. The easiest one to fix is probably going to be the oxygen, so we'll just fix the iron first. So if I have 1 here and 3 here, I'll place a 3 in front of the iron. That's not a 3. Place a 3 in front of the iron. That changes that to a 3. The irons are now happy. And then I have 4 oxygens here, 2 oxygens here. If I place a 2 right there, that'll turn that into a 4. And both sides of the equation are now happy. 3 iron, 4 oxygen, and we now have a happy equation. Problem number 3. 3 elements: calcium, carbon, and oxygen. List them in the same order: calcium, carbon, and oxygen. 1 calcium, 1 carbon, 3 oxygen. This 3, remember, only goes with the oxygen. It does not go with the carbon or the calcium. Go to the right side. I have 1 calcium, 1 carbon. Now when I do the oxygens, I need to be careful. Right here are 2 oxygens. Right here is 1 more oxygen, so that gives me a total of 3 oxygens. Well, if you look, happy, happy, happy. This equation's already balanced as it is. So this one needs no coefficients. It's already balanced. That happens from time to time. Don't freak out when you see it. Problem number 4. Now this one's looks a little nastier, but it actually balances out fairly easily. Let's see. So here's my arrow. Tell me this is where it's split. So on this side I have nitrogen, hydrogen, and oxygen. Nitrogen, hydrogen, oxygen. Remember, always list them in the exact same order. Now when I go to the left to count the nitrogens, I have a nitrogen here and a nitrogen here, so I have 2 nitrogens, 4 hydrogens, 3 oxygens. Go to the other side, the right side. I have 2 nitrogens, 2 hydrogens, and 1, 2 oxygens. Now, again, it looks like the oxygen is going to be a problem because there's 3 and 2, but I found most of the time if something weird like that happens, leave it alone and just see if it kind of works out. So the nitrogens are happy, don't have to do anything with them. I have 4 hydrogen and 2 hydrogens. So to make this into a 4, what coefficient do I need to put here? If I have 2 of them, to make it into 4, I need to put a 2 there. So when I put a 2 there, that 2 times 2 makes this a 4. And then, let's count up my oxygens. This 2 multiplies by this oxygen to give me 2 here, plus 1 more, so that's a total of 3 oxygens. So, 2 nitrogen, good. 4 hydrogen, good. 3 oxygen, good. And that is now a balanced chemical equation. All I needed is this 2 right here to balance it. This 2 right here. And that balances the equation. Okay, the last one we're going to look at today is number 5 from the problem set. Now this one, the thing I found students over the years have had trouble with this kind is they get stuck on this is an I and this is a lowercase l. So you want to be really careful when you're reading these with chlorine and iodine. Sometimes students get confused and they think that all these are I's or this is an L. So this is potassium on the left. We have potassium, iodine, and chlorine. And on the right I have potassium, iodine, and chlorine. And just be careful about the I's and the C's and the L's to make sure you don't get them mixed up. So on the left I have 1 potassium, 1 iodine, 2 chlorine. On the right I have 1 potassium, 2 iodine, and 1 chlorine. Well, the potassiums look okay, don't care about them. The iodines, I need to put a 2 in front of this because I can't put a 2 in there, can't slip it in there, it's got to go in as a coefficient. So that 2 makes this a 2 and this a 2, so now I have 2 potassiums and 2 iodines because of this 2 right here. And so to get this to balance, I'm going to add a 2 in front of this, which is going to make the potassium, that makes that 2, and it makes the chlorine 2. And now I have 2, 2, and 2 on the left, 2, 2, and 2 on the right, and we have a balanced chemical equation. I hope that working through those 5 help you work out the remainder of the problems from Monday. If not, I will be working them in a video that I post on Friday. If you have any other questions, again, feel free to email me. Thank you.